Good morning, folks. Welcome to Shop Talk number 44, or should I say good day, folks, because today we have special guest, Mr. Dr. Trevor Gore from Sydney, Australia. He'll be coming on momentarily, and it's a long way down there to Australia, but we'll see if we can get him up. Thank you for tuning in here, folks. Certainly appreciate you coming in, and I'm always amazed at how many people and the reach that we have all over the world that tune into these little Shop Talk live streams. And so let's just go down the list here. Tom Jacobson from Central Oregon, Rochester, New York. This one didn't put, Scott, I don't know where you're from. Gary from Flagstaff, Arizona. There's another Jeff. Always great to hear from Trevor and Robbie. Well, thank you. Appreciate that. Rob, right here from Denver, Colorado. Boy, he got up early, didn't he? Vancouver Island, BC. Let's see, Chris in Ontario, John Parcham's up there in Seattle. Oh my God. Morning from Tahiti. Wow, man, it must be really late over there where you're at. Missouri, Cesar Tessarin's down there with Manuela. We'll be visiting them in Brazil here shortly. Edmonton, Alberta, Franklin, Tennessee. Oh my God, Lakewood, Colorado, Northern Colorado. It's just amazing how many people tune in here, and I'm really grateful for you guys tuning in. Certainly appreciate it. We're going to have a great show today. We're not going to waste your time. We're also going to give away some prizes, as we always do. So you guys, if you're interested in that, go ahead and sign up. We'll pop down and visit Cesar here in Brazil, and we'll let you know how you can sign up for that. Before we do that, I always like to call attention to the sponsors here at the Lutherie Academy. They're the ones that help keep the lights on, and we want to keep them in business. So let's just drop over to the Lutherie Academy website real quick. If you drop over there, you can see at the top right, there's a sponsors page. Click on that. There's the sponsors. And there are some great sponsors that have all been vetted by me and many others. So let's keep these folks in business. We've been drinking a lot of acoustic coffee this week. They're sponsoring the coffee breaks here at the Trevor Gore masterclass. So let's make sure we keep these folks in business. They've got some great products. Also, the resources page is a new addition to the Lutherie Academy website. A lot of great resources there. Some of them are articles that you can download. Others are external links that talk about just about everything Lutherie related. So make sure you visit that. Also, some online courses coming up. We've got the drafting instrument plans with CAD. That's going to be released here probably in the next week to 10 days or so. And that one, my friends, is going to be a fantastic course. All of the music in there is written by Kristen Young, and he's the one that's actually presenting the course. So not only did he present the course, but he wrote all of the music to go with it. It's a really, really great soundtrack to go with that. So you guys check that out. Also, some recent courses that we've launched here at the Lutherie Academy. Making guitar dovetail joints, everything guitar dovetail related that you would like to know. The history, the jigs, the execution is all in that course done by Canadian luthier Charles Tauber. And also the semi-hollow body course was launched recently. That one was done by Brazilian luthier João Cassias. So make sure you check out all the resources available there at the Lutherie Academy. You will not be disappointed. Let's go down to Brazil. Let's visit with Cesar Tessarin and the beautiful Manuela. Yay, there they are.
Hello.
Welcome aboard. Thank you for tuning in. And Cesar, what can you win if you sign up for the drawing? And how do you do it?
Yeah, so today we are going to give away two special courses, the Falcate bracing and the tuning analysis course. And as usual, participating is quite easy. All you have to do is click at the link at the top of this chat box or go to lutherieacademy.com/live and leave your name and email so we can contact you.
Perfect. All right. Thank you, Cesar Manuela. Nice round of applause for Cesar Manuela. There we go. All right. We'll come back and visit you here at the end of the stream. Thank you so much.
Thank you, Robbie.
All right, folks, go ahead and put in the chat box if you have any questions for Trevor. We're going to bring him up. We're going to pick his brains for the whole hour here. If you have any questions, go ahead and put them in the chat box. I'll try and get to as many as we possibly can. Also, put in there where you're from, because I always enjoy reading after the fact where you're from. Oh, I also forgot to tell you, if you do not win the courses that we're going to be giving away, and you have to be on the live stream here to do that, the majority of the views on the live stream come after the fact. So if you don't win and you're watching this after the fact, I've prepared a couple of special coupon codes for Trevor's online courses. So if you're interested in Trevor's Falcate bracing course, available at the Lutherie Academy, here comes the code. Get ready for this. This is very original. It's Falcate. I know, very original. Capital, all capital letters, Falcate. Put that in the coupon code box as you check out. It will give you 10% off Trevor's Falcate bracing course. If you are interested in his guitar analysis and testing course, here comes the code. You ready for this one? Another original one. Testing is the coupon code. Capital, all caps, TESTING, 10% off. Those coupon codes are valid for the next 7 days. So if you're interested in that, go ahead and purchase those and use the coupon codes. All right. Trevor Gore has been in my shop for at least the last week or 10 days or so. We have been doing a series of master classes on modal tuning. And since he is here in my shop, we decided let's set up the cameras. The last time we did this, we had a green screen behind me. He was actually beside me, and it appeared as if he was in Australia. We didn't go to that trouble this time, but he is over here to my left. I don't know if you're seeing this on my left or my right, but I'm on my left. Trevor Gore, folks. Let's welcome Trevor.
Good day, everybody. Thanks for tuning in, and it's great to be broadcasting to such a wide audience. Hope you're all well and out there in Lutherie land, and that everything's going well for you. So fire in your questions, and I'll do my best to answer them.
All right. Well, thank you, Trevor. I'm going to be switching back and forth between cameras here. He's got his own dedicated camera. I think Dr. Trevor Gore merits that. So we've got we've got his own camera ready to go. So let's go ahead and start firing as many questions as we can at Trevor. I've got an email from somebody this morning that sent a couple of questions. So here we go. First question, bridges and bridge plates with carbon fiber. And this is from Elaine in Tennessee, by the way. So when softer woods are used in place of ebony and rosewood that are the traditional bridges, the carbon fiber design is stiffer and lighter. However, the saddle is resting on this lighter, less dense material. Does it affect tone, sound for the saddle to rest on the lighter, less dense material in carbon fiber design? All right, Trevor, there's your first question. You ready?
Okay, thanks for the question, Elaine, and hope you're well down there. Straight answer, simple answer is no, it doesn't. I use a lot of different woods for bridges. American black walnut is a favorite of mine. I also do a lot in Australian blackwood, both of which are substantially softer than the rosewoods and ebony, of course. So straight answer is no, it doesn't. And if you want some proof of that, if you go to the my website, for example, or the Pacific Rim Tonewoods website, you can hear Miroslav Tadic playing guitars with blackwood and koa bridges, and you'll find that there's no shortage of sound from those guitars. So simple answer, no, it doesn't matter.
Perfect. All right, here we go with question number 2. And this one is also from Elaine. She fired off 2 questions, so she got a bonus question here. Here we go. I believe that the laminated kerfing on the top and side joint has made a big improvement to my steel string guitars. Now I've added live backs to my builds. Why or why not would one laminate kerfings on the back and side joint be another improvement in performance on the live back guitars or not?
Simple answer is I don't know, because I've never tried it. I always use the typical triangular kerfing on the outside type linings for the back, and they've always worked very well. In theory, you might get an improvement if you used solid linings. A bit of the downside of that is that if you got big and solid top linings and big and solid back linings, it means you've got a really big and solid side assembly. And one of the nice things about the way I'm building guitars, the way it's shown in the books, is that you can actually use the sides themselves as part of the whole box to tune the main air resonance by just making them a bit thinner and floppier. And if you want to lower the air resonance of a design that may be perpetually a bit too high in the air resonance, one way of lowering that is to make the sides a bit floppier. If you go to big back braces as well, you'll be limiting your ability to do that. But in theory, it would be a good idea in terms of maybe making the back a bit more live. But there's other ways of making the back a bit more live as well. And I'm just using open kerf triangular linings on the backs, and they seem to work fine.
All right. Next question is going to come from John Parcham, all the way out there in Seattle. How you doing, John? Good to hear from you. Before I get to your question, though, the question has to do with Falcate bracing. And for those that don't know what Falcate bracing is, I'm going to show a picture on my iPad here. Let's just bring that up. That is Falcate bracing, and that was invented by Dr. Trevor Gore over here. In my opinion, the guitar, there are very few people that are responsible for the development of the guitar. One of the people that I recognize is Antonio Torres, and for the classical guitars, and he did the 7-fan bracing. Then you have Martin, and he did the X bracing, and just about everybody copies those two bracing patterns. To a certain extent, you can add the Australian school, the Smallman, the lattice bracing, or the ladder bracing type in the Selmer guitars. But basically, most people are using 7-fan brace or Martin until Trevor Gore came along. And I think he is responsible for much more development in classical and steel string guitar. He came up with something new, and it's refreshing to see that. So here comes his question, John Parcham. Let me just find that again. John Parcham, here we go. Hi, Trevor. Let's see here. On a Falcate classical guitar I am changing the bridge to only using the top layer of carbon fiber and add a bridge patch with an underlayment of carbon fiber. Your thoughts? All right, here you go, Trevor. Take it away.
Yeah, hi, John. Thanks for the question. Hope you're well. Yeah, I mean, what you're essentially doing is moving a classical guitar design more towards a steel string guitar design, because the steel string design has carbon fiber in the bridge and carbon fiber in the bridge plate, and you're forming an I-beam. I think what you're doing will work. It's just another way of adding stiffness to the soundboard in the center and making it all a bit more rigid there. Never tried it, so I don't know exactly what effect it would have on the sound, but it sounds like a sensible sort of idea to give it a go. It'll make the soundboard a bit more stable during construction. If you don't have the facility for keeping the humidity control constant during the whole of the build process. So, for example, a part-built top is transitioning in and out of humidity control. What you can find is that between the braces, be they Falcate bracing or fan braces, you can find that the top corrugates between the fan braces as the humidity changes, and even when you bring it back to 45% relative humidity, you still have these corrugations, and putting a bridge patch on will help guard against that. If you have humidity control constant through the build process and then can put a bridge on that, you won't get that corrugation problem anyway. So it'd be a good experiment to try, John. So give it a go. Let us know how it works out.
Perfect. All right, and I lost John's question here because there's so many questions coming in. There it is. All right, we got San Diego in here. There was a question I wanted to answer. Here we go. Is it possible to correlate bridge rotation and top deflection? I find that my top deflection jig is much simpler and more repeatable. Now, as I get Trevor on to talk about that, let me just show you one of the tests that Trevor runs in his 3-day modal tuning masterclass is this one. You can see there on the iPad, the bridge rotation. And so Trevor, go ahead and answer that question for us, if you would.
Yeah, okay. So we've got two concepts here, the bridge rotation and the top deflection. The bridge rotation test originated to give you a rough idea, a very rough idea of the stiffness in the bracing. So both of these techniques give you an idea of how much stiffness you've got. The idea of the 2 degrees of rotation of the bridge was so that under that amount of rotation and a normal sort of radius curve on the top panel, you didn't end up sending the top into a sort of S shape due to the string torque being applied. So that's where the 2-degree rule comes from. A lot of people seem to be overly wedded to the 2-degree rule, if you like. It really is a pretty rough and ready sort of a rule. And as long as you don't exceed 2 degrees, you won't get the roller coaster top shape. If you're putting carbon fiber in your bridge plate and whatnot, like John suggested before, you'll reduce the rotation of the bridge, which is fine. And then we come into the issue of the top deflection as measured with the monopole mobility rig. And I put much more credence and much more importance on that result, because what you hear when you play the guitar in terms of its responsiveness and volume is the monopole mobility. You don't really hear the bridge rotation. So go for the monopole mobility measurements and try and get it up there as high as you can, and that will give you the responsive guitar. And don't worry too much about the bridge rotation, although both are related to the stiffness of the top.
Perfect. All right. Now he's talking about several tests here. If you're not familiar with the nomenclature of what we're using here, bridge rotation, monopole mobility, all of that, by the way, just happens to be listed and taught in the guitar analysis and testing course. Let me just pull up another picture here. Here's some of the testing we just did. This is measuring the stiffness of plates. We also have testing that we did and measured monopole mobility in the class here. We've been running these classes for several years now. If you ever have a chance to get into one of Trevor Gore's 3-day modal tuning masterclasses, it will change the way you look at the design and construction of the instrument. And your instruments will become better. In fact, I've heard that just being in the same room with Trevor, some of that rubs off on you. He's got some mojo or something going on, and you just automatically start making better guitars. Is that right, Trevor?
It's total black magic, absolutely.
But... All right, let's pull up another question here. Can Falcate bracing be applied to ukulele? That's a great question.
Well, yes, it already has been. If you go to the ANZ Luthiers Forum website and search about in there for Falcate bracing on a ukulele, you'll probably come up with something. And there's a discussion that went on there and on Ukulele Underground, discussing all the aspects and ins and outs of Falcate bracing. It stems from quite a few years ago now, and there's a bit of a internet scrap going on about whether a ukulele could be regarded as a small guitar or whatever. The bottom line of all that is that both of these things have got to respect the laws of physics, and so being a great respecter of the laws of physics myself, I think the same rules apply to ukuleles as apply to guitars. Obviously, one is much smaller than the other, and the frequencies and responses are all a bit different because of that, but basically the same rules apply. So yes, it's been done, and it's been done pretty successfully as far as I could make out.
Perfect. And right after that question came up, somebody said that they built a baritone with carbon fiber and using the Falcate bracing. Here we go. Trevor, you ready to take the gloves off? I mean, we got a question coming up. It's going to take the gloves off here. Here we go. What are the advantages of using laminated guitar sides? Are more lamina better than fewer? That's from Kenneth.
Okay, well, again, the sides of a guitar are much more important than most people think. You can do quite a few things with them that help you along the way. The way I like to use the sides as a sort of tuning structure, there's two things. You can modify the stiffness of the sides, and you can modify the mass, the total mass of the sides. If you're laminating sides, generally they come out stiffer, and there might be some constructional benefits of that. For example, if you do it properly, your sides are going to come out flatter and more stable in terms of their overall shape and whether you've got ripples on them and all of that good stuff. So laminating is beneficial in that respect. However, the downside of that is that once you're committed to laminating, it's pretty difficult to get varying stiffness in the sides. So for example, as I mentioned earlier, you can use the side stiffness as a means of not really tuning the air resonance, but influencing the air resonant frequency, because you can make the sides stiffer or floppier depending on how thick you make them, how many side braces you put in, and that helps you control the main air resonance. That's on the stiffness side. On the mass side, if you use the side mass blocks that I use and came up with it many years ago now, what that allows you to do is govern the mass in the sides. What that does is move the node line of the T112 mode. Getting pretty technical here, but I'm going to carry on with it because most of you guys know what I mean here. What it does is move the node line of the T112 mode outboard. Now, the particular thing about the T112 mode, that's the main wood resonance mode, is that it's like a concentric dipole radiator. That means you're getting sound in one phase of sound from the bridge area of the guitar and the reverse phase from the outer part of the horseshoe around the outside of the guitar. Consequence of that is that you've got a positive and a negative sound radiator, and some of that sound cancels out. So the farther outboard you can move that node line, the more positive radiating surface you have, and the less negative radiating area subtracting from that. So what happens? Well, your guitar gets quite a lot louder, quite substantially louder, and it's a method of trimming the T112 resonant frequency. So that's why it's a really useful technique, and there's no real downsides to it. It's completely reversible. You can bolt on different size masses, and it works really, really well.
Thank you, Trevor. For those that are a little overwhelmed, you have the deer in the headlight look, I suggest you take a walk over to Trevor Gore's website. Let me just pull that up here. This is Trevor Gore's website over there in Australia, goreguitars.com.au. And if you look there at the bottom, there's a tab that you can click on called the book. And if you click on that, then you should have something that pops up here, although it's not. My internet is all there it goes. Well, it's a long way to Australia. Maybe that's the issue. It talks about the books. He's written a design book and a build book. I highly recommend that you order these books, and he will explain about the design and how a guitar works and how to build it and the whole 9 yards. So highly recommended. Go get Trevor Gore's books. Add those to your Lutherie library. You will not regret it. All right, you ready for some more questions, Trevor?
Yeah, absolutely, guys.
Here we go. I mean, you're here for the hours. We might as well use you, right? Here we go. All right. We've talked about laminated. Oh, here we go. Can you talk about the benefits or not of an active back and how to achieve this? Does side bracing automatically preclude an active back?
Straight answer to that, the last question is no, you can make the sides anything you like and it doesn't preclude an active back. Benefits of an active back compared with a non-live back, I use the terms live and non-live. In many respects, you can just regard it as variations in volume and or tone. If you go for a live back, you're stealing some energy from the top in order to drive the live back. The consequence of that is there's less energy there to radiate as sound. So if you're looking for a flat out loud guitar, a non-live back is the way to go. On the other hand, if you make a live back guitar, not only does that put the T113 peak into the frequency response curve, that's a live back peak. Because the live back will vibrate in other modes of vibration as well, it sticks a whole load of other peaks in the frequency response curve. And the more peaks you have in the frequency response curve, the more alluring the sound of the guitar. And this is a result of some research done, I think it was back in the 70s, which basically came to the conclusion if you can stack a lot more resonant peaks in the frequency response curve, you get a much more attractive sound. So when I talk about an alluring sound, that's what I mean. A stack of peaks at the right separation, the right magnitude in the frequency response curve. It's one of the things we talk about in the modal tuning course, how to achieve that. It's obviously in the book as well. And that gives you the effect of a live back. So in very simple terms, a live back gives you tone, and non-live back gives you volume, and you can have either or independent of how you've constructed the sides.
All right. Boy, we've got a lot of great questions coming in here. Here's one from Herman. Herman doesn't say where he's from. Is there any sense to measure frequencies on a non-attached braced plate?
Yeah, well, you can do that, and many people do. The problem is you don't get a whole lot of useful information out of it because it's not a predictor of how that plate will perform once it's attached to the top. And the reason for that is once you attach a top to the rest of the body of the guitar, everything couples together. So you've got air coupling, pneumatic coupling to the sound pressure inside the guitar. So you couple to the air resonance. The back and the top are coupled together both by the sides and by pneumatic coupling due to the pressure changes inside the box. You then add a bridge. You glue down the edges of the plate to the linings. You apply a finish. All sorts of changes happen when you attach the top to the back. And so the exact frequencies that you've got in the top as a free plate are a very poor predictor of what goes on when you attach it to the back and sides. Now, in theory, at least, if you make the tops exactly the same with all the same resonances, the magnitude of resonances, etc., and attach it to a back and side assembly, which is of exactly the same mass as the last one, exactly the same resonances, exactly the same stiffnesses, etc., etc., you should come out with exactly the same result when you join them together. Now, that's the problem with that is getting that degree of exactitude in everything you do is practically an impossibility. So the net result of all of that is that the frequencies, resonances, etc. of a free top bear little correlation to what you get when you measure them when it's all assembled together as a guitar box.
All right, Trevor, I'm just going to keep the questions coming here. What thickness of carbon fiber do you use?
I use carbon fiber cloth. I just buy that. It's a sort of per square meter piece of cloth. It's plain weave cloth. It's 198 or 200 grams per square meter density, if you like. So we're looking at the areal density of this stuff. That's the weight of the cloth. I think it's 3,000 tau, which means there's 3,000 individual carbon fibers per weft of the cloth. You can have a look at this. You can see the cross weave, and I just pull threads out of that and use those when I'm laminating Falcate braces or lattice braces, and those are the threads that go on the top and the back. Now, not all carbon fiber cloth is made equal. I've always used this carbon fiber from the same source in Australia. I don't know who it is who actually makes that carbon fiber. There's no branding on it when I buy it. But the differences between what I've seen over here and what I get in Australia is that if you take a thread of that carbon fiber and run your fingers down it, the stuff I've used over here, you will get a bunch of fluff in your hand if you run your fingers down. The stuff I buy in Australia, if you run your fingers down the thread, you don't get any sort of fluffy fibers coming off. The difference that makes is that if you're brushing out resin over those threads, the stuff I've been using in America tends to bunch up a bit and you get all this fluff, and it's a real pain to handle when you're making something like a Falcate brace guitar. It's not impossible to do that, because in the Falcate video that we did a couple of years back, I used the American stuff, and it was a lot more difficult to handle, but we got there. As you can see, you probably didn't notice much difference in the video, but it's a hell of a lot easier to build using the stuff I use in Australia. But unfortunately, I can't tell you what the difference in brand is or who made it. Clearly, it's made by different people, but I just don't know who makes it. I suspect, though, that the stuff I'm using, I don't know for certain, I suspect it's made by Torrified, T-O-R-A-Y, who are a Japanese company, and a lot of their product goes into the aerospace industry. And I suspect that's who's making the stuff that I get in Australia.
All right, we got a great question coming up now about archtops. Here we go. This is from Gregory. Gregory says, Trevor, Ken Parker has advanced the state of the acoustic archtop. Do you think the strings can drive the top as well when they are anchored at the rim as when anchored in the bridge, as in an archtop or a flat top? What do you think, Trevor?
Well, I'm speculating here basically because I know nothing about archtops. But I think at the end of the day, if you look at the way strings move to drive guitars, the drive works in much the same way. What you don't get in an archtop is the frequency double tension change signal driving the top, because there isn't a mechanism for it to do that. So you're reliant on just the transverse wave in the string driving the top, which is actually the largest drive component from the string into the top. So you'll get some drive there. You won't get the frequency doubled effect. You're also, in general, driving a top that is much higher mass than a flat top guitar would be. So it can be quite difficult, unless you're using very heavy strings and high tensions, to get the sort of volume out of an archtop that you can get out of a flat top. And for example, you don't see many people fingerpicking acoustic archtop guitars. They're all using flat top guitars.
Good. All right. I was just looking here in the chat box, and you're never going to guess who just showed up here. Ray Cutler. Hello from Parker, Colorado, at least for the next 4 days. Ray's in our next 3-day modal tuning class. We've been doing generally every year, every other year or so, we do 2 3-day modal tuning classes. So Trevor comes in a couple of days before the classes begin so that he has time to acclimatize and get scheduled here with the classes. And then we hit the ground running with usually about 15 people in a class. We do 3 days. On the second day, we do a house concert and dinner for everybody. I mean, it's really a lot of fun. And then we have a day off, and then we do another 3 days. This time there was so much demand that we're taking a day off. Today's our day off. And then we're hitting the ground running again with another 3 days. For you guys that are here, Ray's already here. Pedro from Brazil's already here. Here's some of the stuff you're going to be learning. This is running some Chladni patterns. We did this yesterday afternoon in the class. And that would just happen to be a double top. Here's some other guitars that the students have brought. We're checking the monopole, dipole, cross dipole, tripole, all that kind of stuff to determine what the resonant frequencies of the box, the top, and the back are. And Trevor refers to those as T111, T112, T113 in his books. But those are just some of the things that you guys are in for here if you're in class or in town for the class coming up here starting tomorrow morning. 8 o'clock. If you can't be on time, be early, folks. We're going to start 8 o'clock sharp. All right, here we go. Some more questions. This one is from Alexander. Let's see. Hi, Trevor. I built a Falcate Dreadnought using the analyzer and sanded the braces till I got a 2% forward roll. But when I did a tap test, I'm only getting 165 hertz. What is a good number for a dread?
A good number for bridge rotation, probably less than 2 degrees. 2 degrees is very much a maximum. On these larger guitars, you probably need to go a little bit stiffer than that. So head for about half of that. If you're using the Falcate bracing system, size your braces so you're going somewhere smaller than that. A dread will work well at a whole range of different main top resonant frequencies, and they go from 160 through to 190. I don't like the 160 ones because they can tend to get a bit muddy down there, although they may be really loud. The 190 ones are a bit shrill, they're a bit too high pitched. So if you stick with 170, 180, that's not a range, that's two numbers, either 170 hertz or 180 hertz. That's a really nice sounding Dreadnought box.
Perfect. All right. Another question. I have the first version of the design volume. What are the differences with the third version? Can the building volume be purchased alone, as it is the only book I do not have? That's a great question, because Trevor just launched the third edition of the book. I'll let you explain the differences.
Right. Both the second and the third edition are only available as a set. That's just how they get printed and packaged together. So they're only available as a complete set. Now then, I would recommend, there have been a number of additions and minor corrections. I've been very fortunate in there were not too many errors in the first edition, so I've not had to alter too many of those, just the odd minor typo here and there. But there have been various editions over the years. And in broad terms, I would say if you've got edition 1, it's worth upgrading to edition 3. If you haven't got, so if you've got edition 2, probably not worth upgrading to edition 3, though, feel free if you want to, of course. What's different? Edition 3 has a much better indexing. That was the large part of the work involved in doing edition 3. So that will help people find stuff in there. It's a huge book with a massive amount of really good material in there. Finding it was pretty difficult, a specific piece of information. That's now a lot easier in edition 3. In edition 3, I've done a new section on how to stick a transparent pick guard on a guitar and have it almost invisible. So that's in there. From edition 1 to edition 2, I did a bit more on the explanation of some of the source of the errors in intonation, where the errors come from in the first place. Didn't alter any of the analysis or any of the way you address intonation and compensation issues, but just explained a bit more why the problems occur. There's a whole stack of extra information and revisions to some of the pictures and whatnot as you go from edition to edition. And I just cannot remember what they all were, but those are just some of the ones I might mention.
All right, and there's a follow-up question to that from Jeff here. It says, is there going to be a volume 3 of your book? Aha! Anything you can add to?
Well, there's lots of stuff that's not written about in edition 1 and edition 2. Volume 1 and volume 2. I mean, they're both huge books, and there's everything in there that you need to know to make a guitar. But for example, how I make Falcate classicals isn't in there. How I do the tilt neck joint isn't in there. A whole stack of other sort of detailed and peripheral information that we know as luthiers, tricks of the trade that we just couldn't get into the first 2 volumes because there was just not enough room there. So whilst there's a potential for a third volume, which might include a lot more on jigs and tips of construction, I've not contemplated actually collecting that all together yet as a book, and I really don't know whether I'll do that or not. What I might contemplate is whether it can be released in some sort of other format, looking at those topics in another format. So it might be videos, it might be ebooks or something like that. If it turns out, I mean, maybe we can get a level of demand for this measurement either by writing to me or responding somehow to this video saying, well, look, we want a book 3, or we want book 3 in video form or ebook form, and maybe I'll get around to it one day.
All right, so that leaves the door wide open, folks. So let's bug him and see if we can get a volume 3 out there. Here comes Michael's question. What is your opinion on how torrification impacts the sonic properties of the top?
Right, well, first up, I'll say I've never used torrified wood, so I don't have any direct experience from that. What torrification seems to do is sort of age the wood. To an extent, it makes it less dense, increases the stiffness, reduces the strength, i.e. it breaks more easily, and it's more difficult to glue. Now, all of those things, like in any other sort of wood, can be worked around to some extent or other. Having never built a guitar out of torrified wood, I can't say how it changes the sound. In fact, I don't think I've even heard a guitar made out of torrified wood. So, short answer is I don't know. I've not used it, so you might find that there's a message in there somewhere.
Read between the lines, folks. All right, here comes another question from John Parcham up there in Seattle. On flamenco guitars, I use tintelones on the top to the side. I play with the spacing. I thought the influence was impedance of the side to the top. It would also have an effect on the side stiffness, would it not?
Yes, to a small degree, it would affect the side stiffness.
Okay.
Simple answer to that.
Good. All right, here we go. On to the next one. What is the best way to cut carbon fiber mat?
With a pair of scissors.
Very easy, right? Yep. All right, let's go on to the next one. I'm trying to get through as many questions as possible. Here's one from Janie. Is the top bracing more important than the stiffness or species of the top wood?
Oh, well, that's a loaded question. Bottom line of all of that is that there are many, many different types of bracing, and to a large extent, almost all of them will work if designed with some intelligence. So you've only got to look at what's around in the Australian scene. You've got lattices, both dense lattices and sparse lattices. You've got X-brace guitars, of course. You've got ladder brace guitars. You've got Falcate brace guitars. You've got fan braced. You've got the Mardi type fan bracing of 6 fans above the bridge, 5 fans below the bridge. So there's many, many different types of bracing, all of which can be made to work. You've just got to match the stiffness up with the soundboard that you're using. Ultimately, it's the whole of the two together, all of the bracing and all of the top, that makes up the overall stiffness and mass of the top. So you want the overall stiffness and overall mass. If you're looking for a responsive guitar, you want the overall stiffness and the overall mass to do two things. One is to put you in the right resonant frequency zones for the modes of vibration, and the other is to put you in the right level for monopole mobility. And that's all affected by the overall stiffness and the overall mass of the top panel. So there's many ways to get to that end point, and you can use many different species of wood. And somewhere on my website, you'll see a picture, for example, of an old Koa guitar. And that was designed and built in such a way as to give the same sort of performance in terms of volume and tone as a similar size guitar built with a spruce top. Now, there's quite a lot of detail into how that guitar was designed and built, which I won't go into at the moment. But in terms of species per se, it really doesn't matter. You've just got to address it in the right way, and you'll find a way of getting the right stiffness, the right overall mass to get to the resonant frequencies you want and the monopole mobility that you want.
All right. Well, we've gone through a lot of questions here. We're coming up at the end of our broadcast. And I can't believe, I mean, we've had some great questions. I can't believe that some of you have not touched on some of the questions that I had written down previously here that Trevor is actually known for in his guitars. So I'm going to pop out a couple of quick questions here before we end the stream here. So Trevor, you ready? Here we go. You are known, Trevor, for mass loading your guitars. Can you give a quick definition of mass loading to the viewers here and what that does as a result?
Well, we touched on that a little bit earlier, the mass loading of the sides of the guitar. You know, many people think that what you're really after is the lowest mass, total mass of the whole guitar, and that makes for a better guitar. Well, it doesn't necessarily. What you need to control is getting the mass in the right places and the lack of mass in the right places. Adding mass to the sides of a guitar, as I mentioned earlier, moves the Chladni pattern node line of the T112 resonance outboard. So it gives you more in-phase radiating area and less out-of-phase radiating area. There's some more physics to that as to why that works, but that's how it works. That's the net result of that. And it really is the only way of moving that node line outboard to achieve this effect. So adding mass to the sides of the guitar will drop the resonant frequency of the top and make your guitar noticeably louder. And that's why I add side masses to the guitar.
All right, another quick question here, and this may not be a quick answer. Scallop bracing versus ramped bracing. Can you give a quick explanation of perhaps what one would expect tonally if they scallop or if they ramp their braces?
Okay, well, you can probably get the same tonal result out of either method. And you've got to ask yourself, well, what are you actually trying to achieve with a scalloped bracing system? So, for example, when we talk about scalloping, we're usually thinking about X-brace guitars. And as we know, X-brace guitars are quite an asymmetric structure because of the parallel lower face braces. What that does is attempt to give an asymmetric mode of vibration to the top of the guitar. And for example, in a Gibson J45 of a particular era, there was a very strong diagonal dipole, and that diagonal dipole is responsible for the J45 individual sound of the J45 guitars of that era. Now, if you scallop the braces, both the X's and the lower braces, you're actually turning what is a very strongly asymmetric structure into a more symmetric structure. Now, guitar, well, any plate, plate made of any material prefers to vibrate in symmetric modes. And in order to make it vibrate in asymmetric modes, you've got to add a lot of stiffness and consequently a lot of mass to that. So it seems sort of counterintuitive to add all that stiffness and mass to make it asymmetric and then scallop it, which returns it to symmetric. So Is there a difference in sound? Well, probably. Can you make them both sound the same? Probably. If you're looking for a symmetric vibrational performance, which is the most efficient, involves the least mass, you probably wouldn't design in an asymmetric way in the first place. And those of you who've experimented with Falcate bracing, one of the features of that is it's symmetric and it is loud, and that's one of the reasons why. So really, when we talk about scalloping versus tapering the braces, you know, we're fiddling around with the details of a sort of rather archaic bracing system where the original intention of that bracing is now being pretty well forgotten. So I'll leave it there.
All right, another quick question is, most people are tucking the braces into the kerfing, at least on the X brace. Most people these days don't do tone bars and finger braces, they'll extend those to the perimeter. But Trevor, you are keeping the bottom part of the X brace or the bracing in the lower bout when you do X bracing short of the kerfing. What is the reason for that?
Well, if you build in the end of the braces into the kerfing, just the point of building them in, you've got what's called an encastre beam then. That's a sort of built-in structure. And that just the process of building it in to the linings adds about 25% to what would otherwise be the stiffness in that situation. Consequently, it's very easy to make a guitar over stiff, and as a consequence, somewhat less responsive than if you left the braces out of the linings. The argument for putting them into the linings is that it makes the guitar robust, but which is true, but you don't use a responsive guitar as a baseball bat, so why would you need to build it in? So if you're looking for a responsive guitar, don't tuck your brace ends into the linings.
Perfect. All right, another quick question. These are just all design and build type ideas that most people know about. Here comes one. Solid linings versus kerfed linings.
Okay, well, solid linings, by their very nature, tend to have both more stiffness and more mass than a curved lining. If you're using large section reverse kerf linings, you're very much approaching the sort of stiffness and mass you can get out of solid linings. Why would you use heavy linings? Generally, they're beneficial because there's a waveform, a bending waveform that takes place in the top. And when the bending waves in the top reflect from the sides back into the top, they interfere with each other and at certain frequencies will produce a standing wave. And if you look at all the physics of the guitar, it is those standing waves that radiate the vast majority of the sound. So if you have solid linings, you get, in simple terms, more and bigger standing waves and therefore more volume out of your guitar.
All right, another quick question for you, Trevor. Wolf tone. What is a wolf tone and how can we recognize it?
Well, wolf tone is pretty recognizable because it is an overly loud or overly short note duration that takes place at a particular frequency. If that particular frequency is on a played note, typically something like a G, it's very annoying because you hear that clunky sort of sound every time you play a G note or a G chord. And it happens because at that particular frequency, the energy in the string transfers to the top at too fast a rate. And that happens when the string frequency and the resonant frequency of a mode of vibration of the guitar top match too closely. So in order to avoid wolf tones, you need to make sure that the frequencies you play on the string, i.e. the note frequencies, are substantially removed from the resonant frequencies of the guitar body itself. So if you're tuning the resonant frequencies of the guitar top, you want to tune them to frequencies exactly between, that's 50 cents off, the scale tone notes. And that's the best way of avoiding, or that's one way of avoiding wolf tones. There are a few other ways of avoiding wolf tones, but we'll leave it at that at the moment.
Now, for you guys that are curious about what's going on, we've already talked about Trevor's books. Go over to his website, goreguitars.com.au. He's in Australia, and you can get his books. If you happen to be lucky enough to come to his class, here's the last set of victims. This is the 3-day class that ended yesterday. And in that class, we learned how to identify wolf notes and how to manipulate frequencies to eliminate wolf notes. So those are some of the things you're going to learn in the class. And I see some guys here in the chat box that are already arriving in town from various places around the world to take Trevor's class tomorrow. We're running out of time here. We've mentioned the word modal tuning on a couple of occasions throughout the stream here. And here's a guy, Gary down in Arizona. He says, I don't mean to sound totally ignorant, but what exactly is modal tuning? There's been a lot of talking about everything but modal tuning. So let's let Trevor quickly give a definition of modal tuning.
Okay. When a guitar top vibrates, it vibrates in what we call different modes of vibration, which are different subdivisions of the guitar, some parts of which move a lot more than others. And a way of figuring out which parts are moving more than others is to use Chladni patterns. And if you, for example, Google up guitar Chladni patterns, you'll see some of the shapes that form when the guitar resonances respond strongly. Now, the frequencies at which those patterns form are really a very narrow band of frequencies. So there'll be one frequency, for example, of the T top resonance, the main top resonance, where there's a line of tea leaves or whatever you're using as an indicator, forming a ring around inside the guitar. I'm not sure whether Rob is putting up some pictures of this, but he might well do. Yeah. So those different patterns that form are different modes of vibration. So that's what the mode thing is about. That's where the word mode comes from. It's vibrating in different ways. The different ways are called modes. Now, modal tuning is about altering the frequency in terms of what level of hertz or what note that those modes of vibration occur on. And by changing the frequency at which those modes appear, we can alter the sound of the guitar and tune it to our preferred sound. So that's what modal tuning is about. It's taking those different mode shapes and positioning them on the frequency spectrum where we prefer them to get the sound that we want.
Perfect. All right, so we're running out of time here. I do want to ask Trevor just one more question, because we're all here to build better guitars. That's our main goal for watching YouTube videos and getting books and videos and all that kind of stuff. Our purpose is to build a better guitar. The problem is, what the heck is a better guitar? Now, Trevor, in his course and in his books, he has quantified what a better guitar is. So I'm going to let him take us out here and tell us what is his definition of a better guitar.
Well, I normally look at this under three headings. A fourth heading, which I'll omit for the moment, is the sort of graphic design aspects of a guitar, like what color you paint it. So we'll ignore that for the moment. If we go to the other three headings for a better guitar, there is playability, there's structural integrity, and there's musicality. Now, playability is all about things like setting up the action properly, the overall shape of the guitar, whether you use 12 or 14 frets, and it's about matching the sort of physicality of the guitar to the way you want to use it. So that's the playability aspects, and that's reasonably well understood. You know, you can go to your local guitar tech for a setup and whatnot, and help make a guitar more playable. Second section is structural integrity, which is about making sure that the whole guitar as a structure holds together so that the neck stays straight. The thin panels of the soundboard are as lowest mass but will still hold together. All of those things that's where you've got to ensure that the overall structure of the guitar stays stable over time. And that's about the materials you use and how you use them and whether or not you use carbon fiber, etc., etc. And again, that's something probably less well understood than the playability aspects, but is something that I address in the modal tuning course, for example, and of course in the book. It's all in there. And then there's the musicality aspects, which could simply be described as tone and volume. And varying these and controlling these aspects are the least understood area of guitar design and construction. And that's where we spend most time on the modal tuning course, looking at those. So it's things like, how do you make a guitar play evenly at high volume overall, the notes on the fretboard, how you keep the notes sounding similar and not different from note to note, how to change the overall timbre of those notes, and perhaps above all, how you keep it playing in tune, how you make it play in tune to the equal tempered scale, given that one unfortunate fact of making really responsive guitars is that it's more and more difficult. The more responsive you make them, it's more and more difficult to make them play in tune. And that's one of the reasons you can't find responsive guitars in high street shops, because there are so many sort of downsides of making a highly responsive guitar that it takes a lot of time and technique to overcome all of these downsides. And that's what the modal tuning course is all about, is how to make a highly responsive guitar that'll still play really nicely, sound really good, have an alluring sound, which we have a strict definition for, and how to do it, and how to make it play in tune. So that's what a really good guitar is it satisfies all those criteria of playability, structural integrity, and musicality.
Perfect. Now you guys have it quantified. You have your definitions, so go out and make better guitars. That's the goal here. I told Trevor that was going to be the last question. However, I just had a really interesting question pop up here from Gregory. Let's just try one more, then we got to do a hard break. We got things to do. And we have a hockey game to go to today, too. My daughter's playing in a tournament here in Colorado, so we got to go check out the hockey game. But here's the question. Trevor, by my calculations, about 80% of the mass of the top is in the panel, and about 80% of the stiffness is from the braces. If mass is the enemy, then shouldn't we try for the thinnest panel?
Well, yeah, and if you look at what's going on, certainly in the Australian zone, you have people like Greg Smallman building classical guitars, where the panel thickness is well sub a millimeter, well less than a millimeter, and the bracing is balsa wood and carbon fiber. And in that way, using carbon fiber for the stiffness and keeping the mass down by using thin panels, yet you get a more responsive guitar. However, if you go too low, you turn your guitar into a banjo, which is fine if you like banjos, but if you want it to sound like a guitar, you've got to keep the overall mass and stiffness in the right zone. If you go overly stiff and overly heavy, you get your typical high street shop guitar, which is only about 50% as good as it could be. And that's what I call the conspiracy against guitarists. All of these manufacturers are telling you they are selling you the best guitar that money can buy, the best thing since sliced bread, when in fact it's only about 50% as good as it could be. And I've measured that, and I know it's 50%. So that, why I use that term, all explained in the course and in the book. But that's the conspiracy against guitarists. What you can normally buy is only about as 50% as good as it could be.
Perfect. All right. Well, we've had quite a great conversation here with Dr. Trevor Gore from Australia. Let's pop down to Brazil real quick. Let's wake up Cesar and Manuela, because I'm sure they're probably asleep by now. Let's see. Oh, there they are. How you doing down there, Cesar?
Way too much interesting information. So
All right.
we have 57 participants for this
57
round,
participants.
and you're going to make 2 drawings. So
All right,
let's do
the the Falcate first. Is that okay?
Yeah. For the Falcate bracing, let's see, Manala. And we have number 54.
Look at that. That's Tim Kelly.
Tim
He
Kelly.
was just here for Trevor's modal tuning class here just a few days ago. Congratulations to Tim Kelly.
Congratulations.
All right, let's also give away the guitar analysis and testing course.
Second round, let's go. And we have number 42, which is Dave Anthony.
Dave Anthony. Congratulations to Dave Anthony. All right, so Cesar will be in touch and getting your contact information and getting you guys access to the courses that you won. Interesting, I had a guy, Cesar, this is pretty interesting. I had a guy in our last class that came up to me after the class and says, you know, because of work, I'm not able to watch the shop talks very often. And I've only been able to watch 3 of them live, and the rest I watch after they're live. But of those 3 that I've watched, I won 2 of the prizes.
Okay.
So he says, I've never won anything in my life, so this is amazing.
Yeah, it's amazing.
All right, thank you very much, Cesar and Manuela, and
Thank you.
we'll look forward to seeing you on the next Shop Talk. All right, folks, we need to have a hard break here. Trevor and I have got a long list of things to do today, including the hockey game, as I mentioned. Thank you to Jim Deeming for the wonderful theme song here. Jim's going to be performing for us here tomorrow night, Sunday night at the 3rd and final modal tuning class, which is our 3rd and final house concert. Go ahead and check out Trevor's website. His books are for sale directly from his website. Also, the coupon code for you guys watching this stream for the next 7 days. If you want to get his Falcate bracing course, use the coupon code capital, all caps, FALCATE. Get 10% off the Falcate bracing course. If you want to get his guitar analysis and testing course, all caps, testing, TESTING, you get 10% off of those. Obviously, those are available at the lutherieacademy.com. All right. Well, thank you so much for everybody for participating. I hope this is giving you enough information to go out and make better guitars. Thank you very much. Over and out, folks.